Hi there, today I'm going to show you a device to help you prepare stock for woodworking when milling wood to thickness. Now let's take a step back, discuss milling and why it can be a lot of effort. Now some woodworkers leave all this to the vendor. Either it's thickness and pre-surfaced at the time of sale, or most lumber yards will do that for an extra fee. Now, being able to mill wood yourself opens up new possibilities. You'll be able to use stuff like rough sawn wood and construction lumber, and you can also correct wood that may have moved while resawing or while acclimating to your shop. The milling process has two main steps. First, you flatten one face of a board, and then using the flat face as a reference, you cut off the excess from the other face to bring it to thickness. Now, this video is all about flattening the first face. So how do you do that? Well, there are two mainstream approaches. The traditional way is to use hand planes to flatten the board. If you've never done this before, it's really worth experiencing, and you'll learn a lot from it. I did it this way for years. The drawback is that it can be time-consuming and labor-intensive. If you're a hobbyist woodworker with only a limited number of hours to spend working, you can wear yourself out and get discouraged from actually working on any projects because of this initial hurdle. The other way to flatten a board is one you may already know. You make multiple passes over a machine called a jointer. This approach is quicker, but has a few disadvantages. First, the width capacity of most jointers is limited. The most common models are 4 and 6 inch models, and they get really expensive above that. They're big, heavy machines, they can be fussy to set up, and they're not particularly safe. But when they work, they work. Now let's think about what happens after we flatten one face, bringing the board to thickness. Again, you can use hand planes to do this, as I did for this workbench, but this really is a lot of work. And for that reason, even many hand tool woodworkers turn to a machine called a thickness planer to do this horrible grunt work. Thickness planers have cutting mechanisms similar to jointers, but usually have a much wider capacity. A really big draw for the hobbyist woodworker is that there are portable benchtop machines that are less expensive, relatively compact, yet still do a pretty good job. My planer is one of these so-called lunchbox styles and has a 12-inch capacity. You might ask yourself, well, these thicknessing machines use the same basic cutting mechanism as a jointer. Is there any way I can use one to flatten wood as well? Well, unfortunately, there are a few reasons why you can't just feed in the wood to get it flat. But the short version is that the thickness planer is designed to cut one face relative to the opposite face. And that opposite face is not necessarily flat. Now, there are some combination planer jointer machines, but they are real beasts. So, this gets you thinking, hey, has anyone thought of some way to feed a piece of wood into a thickness planer so that it can flatten wood? Some sort of sled to hold the wood as it goes through the planer? And the answer is yes, and there are lots of planer sled designs out there. Most of them are meant to provide a flattening solution when a board is too wide to fit on a typical jointer. Unfortunately, these sled designs have a variety of drawbacks. They can be really heavy, complicated to build, complicated and time-consuming to set up, tricky to use, and some require consumables such as hot glue. I gave a lot of thought to these problems and what was going on in these designs. And over the last year and a half, I developed and tested a new kind of planer sled. It's intended not just for wide boards, but also standard ones that you would otherwise use a jointer on. I've used the sled for all of my recent projects, and it's been a real time saver, and I'd like to share it with you. My design has only one really important requirement. You need a flat reference surface. And here's mine, my bench top. It's mostly flat. You don't need to use a bench. If you've got something flat and relatively inflexible, you can use it. You might even be able to use a big old table saw. I guess that might make it useful. Or if you really have to scratch that torsion box itch, I guess you could do that. And here's the planer sled itself. I call it the Multiwedge planer sled because you set it up with a bunch of specialized wedges. Now this thing is as simple to construct as it looks, so instead of boring you with the build details, I'm going to show you how to use it first, then come back and discuss what makes it work. The first thing you do is clamp the sled to your reference surface. You want the sled flush against the reference so that whatever you're trying to flatten will follow the reference surface, which is supposed to be flat. Now, grab your board and look at its profile. You want to put any convex side down onto the sled. For warp boards, just try to find the most convex side. Put the end up against the stop at the end of the sled and try to get the grain direction correct with the grain running uphill from the stopped end of the sled. You're going to feed that end of the sled in first. Now ideally you should be able to rock the board around at this point like this, and I'll tell you why later. You'll start fixing the board and the sled with these things that I call lateral stops. They're really easy to make and they keep the board from sliding side to side on the sled. All you do is slide them into these narrow channels like this, and then use these small fixing wedges to lock the board into place. For these lateral stops, and only the lateral stops, you want to take the extra step of banging them in so that they will not easily come out. At this point, the board will still rock, but it won't be as easy. Now you're going to eliminate the rest of the rocking. Take these wedges, which I call support wedges, and slide them up under the board so that they just barely touch. Unlike the lateral stops, use a very light touch. Don't let the board move at all. Just slide until they stop. Now when you put in each support wedge, gently fix it in place with a fixing wedge. Take care not to accidentally shove the support wedge any further under the board. It helps to press down on the support wedge during this process. And again, you don't want to use a lot of force because this can introduce errors. And keep your hands off of the board when putting in the support wedges. Support wedges go in from each side. When you've finished with all the support wedges, try rocking the board. It should not move. Inspect the support wedges. Press down on the board over the wedges to see if there's a gap there. Very small gaps probably won't cause problems. Now you might be worried about the overhang of the rear of the board. We're going to talk about that later. And that's all there is to the prep work. It only takes a few minutes. You're ready to take off the clamps and take the whole thing over to the thickness planer. Feeding the sled into the planer is relatively simple and similar to normal operation, but there are a few things to keep in mind. First, although this sled is relatively lightweight, it does help to have an inexpensive roller stand to rest it on as you're making your initial and incremental adjustments. You're going to feed in the sled with the end stop first. Press down on the end of the board as you're trying to gauge your first pass. I try to keep the first pass light. It's totally fine if you whiff on the first pass and it doesn't even cut anything. What you're trying to avoid is trying to cut too much and getting the whole mess stuck in the planer. Some boards are really uneven, and if there's a high section in the middle of a cut, there's a risk of a jam. But if it gets stuck, don't panic. You can recover by just switching off the planer and adjusting the depth. On your first passes, you might also run into a section where the feed doesn't quite grab the board. You can push in the sled by hand if you run into a section like this. This might actually happen with this board because there's a significant bow here. So here's our first pass. Feed it in. When everything is sufficiently engaged, go to the other side and check it out. If the sled is really flexible, you might need to make sure that the board stays registered against the end stop, but this usually isn't a problem. When the cut is finished, you'll need to pull out the rest of the sled by hand. If you turn off the planer before doing this, you won't run the risk of accidentally cutting into the sled. This was an excellent first pass. We took off just a little bit of material from the whole length of the board. Now you can take it back around for another pass to take off a little more material. Subsequent passes should be more predictable than the first one. Be careful not to bump the support wedges when you handle the sled. You're done when the machine can cut off a bit of the entire face in one pass. Sometimes it's hard to tell, so if you're not sure, mark up the face with a pencil before taking a cut and see if those pencil lines are gone after a pass. When you're done, take the board back to your reference surface. You may want to mark the grain direction on the face. Now you can verify that the new face of the board is flat, or at least flat enough for your purposes. You can check it with straight edges, a winding stick, or just slap it face down on your reference surface. At this point, the board's face is in usually pretty decent shape, but you still have to thickness the board to get the other face flat. You have to go back to the planer for this, but you're done with the sled. And you have a chance to refine it a bit more here. There might be some slight dips in planer snipe that you can reduce. With the newly flattened face on the bottom, run the board through the thickness planer until you're taking a full cut. Then you can flip the board over again so that the initial face is on the top, and take some light cuts. If there are any slight abnormalities, this will take care of them, and it should also reduce but not eliminate any planer snipe. The sled can deepen planer snipe somewhat due to its weight. A great way to refine the board is to take it back to your bench and use a hand plane to completely eliminate the snipe and other planer cut marks. It shouldn't take you long to get full-length shavings. So now you've got a board both flattened and thicknessed with your planer. Now of course there are all sorts of crazy things that can happen when you're milling wood. For example, if you cut off a lot of thickness from a tough piece of flat sawn hardwood, it'll often cup up again as you release tension between outer and inner growth rings. But that's a subject for another video if you really want to hear about it. So now that you see how this all works, let's talk about the sled and how you can build one. The construction of this sled is almost as dumb as it looks, but there are some things I learned along the way that should prove helpful. This is not the first one that I built. It really is just a bunch of plywood rectangles face glued to a big plywood base so that you get a bunch of crosswise channels. It's 1/2-inch pine plywood. And like most plywood, this is not very good plywood, and it doesn't lie flat, which is one reason why you clamp it to the reference surface when setting up the sled. You know, you just can't trust plywood. The pine plywood I used here was fairly inexpensive, and more importantly, it's light. This makes it easier to carry around and manipulate around the planer. The prototype I made was of maple plywood, which was more of a chore. The end stop here is nothing special. It's just a strip of wood glued down right at the edge of the first channel. It's important that it's right at the edge, because the infeed roller on a planer grips a board very tightly, and if there's a small gap here, the rear of the board can flip up upon initial feed. The main channels for the support wedges are about 1.5 inches wide, spaced about 4 inches apart. The channels for the lateral stops are about 1 inch wide. There's one lateral stop channel near the end that you'll always use, and then there are a couple more spaced along the length that you'll use for another pair. Most of the time you'll use 2 pairs of stops, but you can get away with 1 pair with short work pieces. Now I'm considering altering the design to just add narrow slots the whole way down. Glued to one side of every channel is a strip of fine grit sandpaper. This is the side that the support wedge or lateral stop is shoved against. This discourages those parts from wandering around during use. Now let's talk about all those wedges. All the wedging angles are 10 degrees. I made everything with my bandsaw on a sliding miter fence, but you could do it with a handsaw. If you do it by hand, do yourself a favor and make a custom miter box. I guess you could also use a table saw if that's your thing. The support wedges each have 2 miter cuts. The first is the cut that forms the support surface. The second is the edge where you fit the fixing wedge. This results in the widest part being the lowest part of the wedge that slides under the work, and the highest part being the narrowest. The order of cuts is a little tricky to visualize at first, but once you get the hang of it, it's not so bad. These support wedges should be made of a good, tough, hard wood that doesn't compress easily. Mine are made of ash. I used tulip tree for a few of my prototype and they dented a bit. The only thing I personally wouldn't use is oak because the tannins turn my hands purple. The lateral stops are easy. They're just L shapes that need just one mitered cut for the fixing wedge. Now you may have noticed that the support wedges are labeled A or B. These are just mirror images that are used on one side or the other. This is the A side and this is the B side. I didn't label them on my prototype and I was always trying to figure out which was which, so I just wrote them on with a Sharpie. The high sides of these particular wedges are quite high, probably way more than I need. This makes them easier to slide into place. But when flattening boards that approach the maximum width of your thickness planer, they can jut out past the edges of the sled. If this is a problem, you can make wedges without such high ends. And as for those fixing wedges that hold the supports and stops in place, use the softest wood you have on hand because it will compress more easily. This helps them hold in place more easily when you put them in by hand. I think mine are a mix of eastern white pine and western red cedar. There are varying sizes. You'll get a feel for which size is right as you experiment. And finally, I've waxed the bottom of this to help it better slide through the planer. This is normal paste wax, but you could also hot wax it like you would for skis or a snowboard. Now let's talk about some operational details and limitations. Earlier I said you want to put the board's convex side down on the sled. That's because you want to provide solid support underneath the highest points of the board as you're cutting it. Imagine you have a cup board like this. The feed rollers on a planer push down really hard, enough to bend boards that aren't extra thick. Watch what happens if you push down on this board if you put the concave side down. There's no support in the middle at this high spot, so the whole board just squishes down and you won't get a flat surface. But if you put the convex side down and then put wedges underneath the edges, as the support wedges in the sled do, the rollers cannot smash the board down at the edges and deform your cut. I said earlier that if you take a lot of thickness off a hard flat sawn board, it will probably cup a little because of relieved tension. It's really no different than what you'd experience if you did it by hand or some other way. If it's really bad and you suspect that it's going to be bad, you can always leave a little extra thickness and repeat the flattening. Now some boards are warped. Just deal with them the same way. Try to find a convex side and put that side down. It'll be fine because the highest spots should still lie underneath the support wedges. Be careful not to bump the support wedges when you're handling the sled. They won't back out, but you can accidentally push them in, causing a concavity like this one that I made into a back panel of a drawer. Remember when I talked about the overhang in the rear? This is only a concern if you have a long overhang and your board is bowed enough so that it won't register against the bottom at the very end. The front might flip up a little upon going through the rear feed roller. The easiest way to deal with this is just to hold the board and sled together as the planer finishes its cut. Another possible way to address this is to make a narrow lateral support channel between every two wide channels. That way you could use special narrow support wedges for this kind of situation. I didn't do that on this sled because it didn't occur to me. So far it hasn't made much of a difference. You could also tape down a couple wedges in the very rear. You might not be able to fit in boards quite as wide as your planer sled because you need a little bit of space near the edges to put the support wedges and the lateral stops. The widest stock I've flattened on this 12-inch sled was 11 inches. But I think I could fit in a little bit more by shortening the support wedges. It would give at least a ½ inch. My thickness planer's design actually allows me to put in stuff that overhangs the edges of the planer sled by about 12 millimeters on each side. Apart from the maximum, there's a minimum board width. There's something like an 1.5 inch hard limit on my wedges because they extend inward a bit, but that's not necessary. I don't bother with using the sled on that kind of stuff anyway because it's easier to flatten with a jointer plane. So this sled is about 4.5 feet long. If you need to flatten longer stock, you can make a longer sled. I have a second one that's 7.5 feet long. But I encourage you to make a shorter one for most of your work because it's much easier to handle. Most of the stuff that you'll flatten won't be long. I originally built that long sled to help out with my daybed project, which has a long table-like platform. The first project I used the sled on was my coffee table project. Its next task was what I call the auxiliary bench, which you see here. It was my experience with this project that really convinced me that I might have made something useful. You can see that the bench has a lot of southern yellow pine 2x stock that's been face glued. For the top here, I was able to flatten and thickness each board very quickly. Once I had a group of about 8 to 10 inches worth of boards glued up, I was able to put the whole group on the sled, then flatten and thickness all of that in one shot. After I had 3 of these groups made, I had no trouble gluing them to make the whole top. The legs and stretchers are similar with a twist. Take a look at this leg. I flattened and face glued boards yet again, which left me with a thick post, but with 2 faces uneven. I was able to put it onto the sled yet again, but this time sitting 90 degrees to the already flat faces. This allowed me to get all the sides square into proper dimensions quickly. This certainly wouldn't work for everything, but for something of this size, it does work. Other shop stuff I've made with the sled include my bench on bench, the top for a stake saw bench, and a stand for my drill press. And of course, almost every new furniture project has used the sled now. So overall, milling wood is no longer a significant amount of work on a project. This sled has saved me a lot of time. It was cheap and easy to make. Setting up a board for flattening is reasonably quick, and because it's light, I can easily handle it by myself. And it might work for you too.